All right, so the purpose of this video is to review physics classroom, specifically Minds on Physics RL8, Converging Lenses and Ray Tracing. And I'm doing this from the standpoint of a CAD program, which I think helps show some of this. To start with, on a converging lens, and diverging lens is also a similar situation. There are three main rules, and I'll show them the three here, but rays passing through the center go straight through without reflections. That's actually the same case for diverging as well. They're the exact same situation, and I would show what that would look like here. So if a ray comes in, and this is the incident side here, it just goes straight through. Here's another example. These are straight lines. These are just examples. Similar would happen here. The first rule is the same. Rays come in. If they go through the center, they pass through without any incident. I'm going to move that up out of the way. Where we start getting a little difference between the two, converging and diverging, is when we deal with this rays coming in parallel. And so what this would look like, I've got three here, you can see. If a ray comes in parallel, and that would be an example by them coming in over here on this side, on the left side, they come in parallel. They all diverge through the focus. And then the third, and then we'll show conversely on a diverging lens, if they come in parallel, they all diverge, and I have a couple examples here. If they come in parallel, you're going to see that they diverge, or they refract away outward, as if they had started, if you work backwards, to the focus on the same side. So in a diverging, it's all about the focus on the same side as it started. On a converging lens, it's all about the focus on the opposite side when they come in parallel. Now we do the exact opposite when we look at rays passing through the focus on a converging lens. So if a ray comes in here, we can show a couple scenarios where this ray would come in, pass through the focus. It's going to refract out parallel. Another example here, I have two examples. It comes through the focus and it refracts out parallel over here. It is worth noting, even if the light started here, as if it had started there, if the light came along this angle here, it would refract parallel. So it's all about being on this line right there. And then on a diverging lens, it's very similar, but a slight difference. In that case, it's all about coming in as if it's headed towards the focal point on the other side, as if it was going there with the dashed line. I'm showing you what if it did like that. In fact, it would refract parallel. So those are the three principal things that happen that you can always bear in mind. Those are the three rules. I've got them over here. We'll start by looking at RL8. And so if you look at these scenarios here, we can look at, and I don't know that I'm going to do all these, but I'll at least do a few of them. We can look at this and we can say, well, what would really be happening? And if we start here, we always want to know through the center straight. Well, that's going to be 4. So 4 would be correct. Okay. Is something going, since this is a converging, is something going through the focus? Yeah, 1 is, and this should go out parallel. So we know 3 would be true. Is something going in parallel? Parallel in, so that would be this second one here, and that would be item 2, comes in parallel, but does it refract through the focus? No, it's going through 2F, so no, that wouldn't work. So in this case, the only 2 true ones would be 3 and 4. If we move down to another scenario, this is another question you might see. The diagram in this one, let's go through our rules again. Is there one going through the center? And this is where, although 5 is in fact true. This is not an awesome graphic. There is a slight deflection in that. If you're really good at seeing straight lines like I am, it slightly does bend, but it's going to want you to assume that that's a straight line. So 5 would be true. 1 would be true because it's coming in through the focus. So look at 1. Although the line doesn't actually start down here and go through the focus, it's as if it went through the focus. And so then it goes out parallel. So 1 would be true. And then do you have anything coming in parallel? In fact, you do. That's the final one here, parallel in. That would be 4. Comes in parallel and then goes down through the focus. So the others would not be true, but in this case, 1, 4, and 5 would be correct. If we keep moving down, look at our 3 rules. Is anything straight through the center? Yes, 3 is. Does anything come in parallel? 4 does. Does it go through the focus? Yes, so 4 is true. Does anything come in through the focus? 2 does come in through the focus, and it does in fact go parallel, so that one would be true. All of the others just wouldn't be true because they don't follow those 3 rules. We'll just keep going here. It's a little bit different. It's saying which ones correctly show the diagrams, and when you get to this point, you can kind of do a similar scenario. Think about what's going on. You have a parallel line, should refract through the focus. Is that what it would do? Yeah, it would do that. Here you have one go through the focus, it refracts parallel. Is that in fact what we do? Yeah, that would follow the rules. So diagram A would in fact be true. What about if we move over here to B? In this case, we have one going through the center. That would be true. But this is not really true. This ray coming in here, we have no reason that that would go through the focus. So B would not be true. And then when we look at C, you have parallel in, should go through the focus. That's true. Coming in through the center, that's true. And in fact, so C would be true as well. There would be no image. I would like to pause here and just say, if you aren't doing this, when you go into these, there are 2 different places that you can be looking. There is a geometric optics in FET basics. They're linked normally for you, but you can always find it there. And then there's also just plain old geometric optics, and it's not basics. These are useful because the geometric optics has converging and converging lenses, whereas the basics allows you to show 1F and 2F by clicking this on and off. And when you're doing these, if you're really struggling, you may find it worth your time to be pulling those up. But we'll continue down here. This one, it's saying which one would be correct. And so we could go in and we could, again, follow our rules. So here we have the origin is from the red. So we have this going as if it came from the focus, refracting parallel. That's a true. We have going through the center, staying straight. That would be true. If you go backwards between the 2, that would in fact work. So diagram A would be good. If you look at diagram B, straight through the center, that's a true. That would follow the rule. This one, does it go through the focal point and go parallel out? Yeah, that would be true. So diagram B would work. And this one we have going through the focus, refracting parallel. That would be true. Parallel in, refracting through the focal. So that would be true. So in fact, all 3 of those would be true. At this point, I'm going to end this. I don't know that there's any point. Oh, yeah, I guess we have one more. We'll just do the last one. So in this one, we would do the similar thing. Parallel in, refract through the focus. That's true. This one is an extension of 2F and trying to say parallel. No, absolutely not. This would not work. And in fact, if an image is sitting on the focal point, there is no, if the object is on the focal point, there is no image. If we bump over here to B, parallel in through the focus, yes. Through the focus, parallel out, that would be yes. So B would be true. And here, this one would in fact be true because we have this one is in fact through the focus, parallel out, and then through the center, staying straight. And if we work backwards, we would have a virtual image. And so in fact, C would be true as well. I'm going to stop this here. I will do another video where I walk through a couple other things, and I'll show you what goes on with the diverging side. Thank you and best wishes.